This is the screencast for section 3.1, example 3. We're going to find an exponential function from its table of values. So the directions say determine formulas for the exponential functions g and h. So we're going to do two separate functions whose values are given in table 3.2. So here's my x values and here are my y values for g. I'm going to do g of x first. Now it says that g of x is an exponential function. So I already know that g of x is going to come in the form a times b to the x. So what I can do is I can plug in, let's see, the initial value 0, 4 for x and y, and then solve for a. B to the 0 is 1. So a equals 4. My initial value is 4. So far I've got g of x equals 4 times b to the x. Now I can plug in a second point. Let's see, an easy one. Fractions are not easy. How about 1 comma 12? So I'm going to plug in 1 comma 12 and solve for b. So I get b equals 3. So now I have my final equation, y equals a, which is 4, times b, which is 3, to the x. Now if you look at g of x's y values, they are multiples of 3 apart. If you take f of negative 2 and multiply by 3, you get f of negative 1. If you take f of negative 1 and multiply by 3, you get f of 0. 4 times 3 is 12, 12 times 3 is 36, etc. These are growing exponentially by a factor of 3. Now we can do the same procedure for h of x. H of x is going to be an exponential function, a times b to the x. I'm going to plug in its initial value first, 0, 8. So I'm going to plug in 8 for the output and 0 for the input. B to the 0 is 1, so a equals 8. So far I have h of x equals 8 times b to the x. Now I'm going to plug in another easy point. I think 1 comma 2 is easy. Maybe you think 2 comma 1/2 is easy. I don't know, it's up to you. So I'm going to plug in 2 for y and then 1 for x. Divide both sides by 8. 1/4 equals the b value. So this equation is y equals the a value times the b value to the x power. So this is exponential decay. So I can see that every single time, every new y value is getting multiplied by 1/4 to achieve the next one. 128 times 1/4, or divided by 4, is 32. 32 divided by 4 is 8. 8 divided by 4 is 2. 2 divided by 1/2 is, divided by 4 is 1/2. 1/2 divided by 4 would then be 1/8, etc. Now I can look at my calculator and graph g of x in y1 and make sure it goes through each of these points, -2, 4/9, -1, 4/3, 0, 4, etc. And then I could also graph h of x and make sure that that graph passes through its points, -2, 128, -132, 0, 8, 1, 2, and 2, 1/2. If I came up with the right equation, this equation should pass through every single one of those points. The now try problem is example 11. Determine a formula for the exponential function. So it's telling you f of x equals a times b to the x. It is an exponential function, so x is in the exponent. So 11 is specifically asking for f of x, so for this case we are going to ignore g of x. I'm sure you'll use that in another problem somewhere. I'm going to plug in the initial value first because then b can get canceled out because it will have a 0 exponent. So I'm going to plug in 3/2 for f of x, the output, and then 0 for b. B to the 0 is 1, so a equals 3/2. So far I have f of x equals 3/2 times b to the x. Now I pick another point that's easy. None of these points are super easy, but maybe you want to plug in 1, 3/4. I'm going to try -1, 3. So I'm going to plug in 3 for the output, -1 for the exponent, and now I get, let's see, divide both sides by 3/2. So I get, let's see, 6/3, so that's 2 equals b to the negative 1. Raise both sides to the negative 1 power, and I get 1/2 equals b. Therefore, f of x equals, let's see, my a value was 3/2 times 1/2 to the x power. Now your solving for b will probably look different than mine depending on what exponent you used when you tried it. You might have had to take the square root of both sides. You might not have had to done anything. You might have had to raise your exponent to the negative 1/2 power to get rid of the negative 2 power. Just depends.